Well, we talked about Linux. What about BSD and what about other Unix systems? Solaris was a leader in Unix. It took the BSD systems, made them very popular, and then improved upon them. So we should look at Solaris perhaps as a sort of example of how the Unix as opposed to Linux world dealt with virtualization. And Solaris zones were a sort of early type of virtualization. They came in about the same time as Linux, but they were, this is all before current modern events and before the cloud. So what were Solaris zones? Again, very similar concepts. You're trying to provide virtualization. In this case, you're using, yet again, virtualized operating systems. The operating systems are going to provide that virtualization. It's going to be a logical sort of separation of systems. You're going to be able to share files, processes, and network interfaces. And one of the nice things about these type of zones is that they actually accommodate sharing them, though sharing between zones as opposed to isolating completely between zones. So they'll actually do the mapping that's necessary with the namespace and so on to allow that sharing to occur. The scaling and sharing can be configured basically as you need it, and individual zones can gain files and configurations. To situate the whole thing, there's a global zone, and then you can create other zones from that to do different tasks. So if you were going to build, say, a very complicated web service type of operation, you could create that in a zone on a machine, and then you could subdivide the zone. You could have other zones that handle just specific things like executing the user scripts coming back from HTTP. So there's some benefits, a little bit more control perhaps than the Linux world, and the whole thing taken into a Unix world. So there's a global zone. All Solaris 10 had global zones attached to them, and this global zone is bootable from the system hardware. It's just part of the system, and contains all of Solaris, and can contain additional software, anything you want to install. The local zones are a subset of the complete operating system. If you like, what you're saying is, well, I've got everything, and now I'm going to provide particular environments for my services that I'm going to provide on Solaris. So I will subset what I've got in the big zone for that purpose. And so you just allocate in those local zones particular pieces of the whole zone, and you can actually add non-shared packages if you want. The local zones, if they don't have a sharing arrangement specifically, they have no awareness of the other zones. It's almost like a tree, and as you move down the tree, you inherit stuff, but the leaves can't talk to each other. So a local zone can't install, manage, or uninstall itself, and it can't do that to any other zone. It's got to be the higher up the hierarchy zone that does that. So you have a zone administrator that manages building these zones, shutting them down, allocating zones, and starting scheduling. You can see it's a very hierarchical approach to the problem, very reflective of the way that Unix thinks about the world. The zone administrator allows you to allocate devices and allows you to plumb the devices together, so you can actually create arbitrary structures and communications between zones if you want, but that's all sort of programmable, because it would interfere with the isolation notions. And then you also have managing the file systems. You can share files between zones. That's again on a zone administration, so it's a little bit more flexible than we were talking about before. The scheduler manages thread management per zone. The threads are little processes. They're not the Unix processes, they're the individual threads. can do context switching between the threads. Doesn't change your VM. They all operate within the same virtual memory. So the kernel threads are doing the work on behalf of the zone, and they're all owned by the scheduler. So you have a root, again, which leads to all the individual pieces. The zone file systems, you have two different models of how they build the file systems for the zones. One's a sparse root model. Minimum number of files from the global zone are provided to that zone, and shared files are mounted via read-only, and then they loop back. So that approach, you just get a very, very sort of limited view of what actually is in the whole system. The other approach is to give you a whole root model. There's no dependency or shared file systems. What you're getting is a root, and then you build things up from there. And I think that's pretty much what I want to say about that. Zones have visibility to each other via network interfaces. So if you want to talk between zones, you can communicate using sockets. You can obviously communicate through the Ethernet if you really want to write all that code. The global zone administrator can modify those interfaces and routes so they're reconfigurable. And then you have the communications being in the global zone, you can extend and so on if you really want to. And the same thing with the sort of failures, events, and so on. They're all configurable from the global zone into the local zones. So one of the key purposes of this system was actually to control resources. So there is a rather large amount of effort in constraining how much physical memory, how much time, how many threads, how many kernel pages are being used, how many are mapped into real memory. All of these things can be capped and resource managed from the global zone to the individual zones. So you can actually sort of place restrictions on one of these zones you've built so that it is constrained to operate within a set of limited resources, won't exceed it and won't place too much handicap on the rest of the system. So that's this Solaris zoning system. Now let's move on to containers.